They start us off here with the word of caution, and we've already talked about it, but it's talking about the domain of log base a of x is 0 to infinity. They're just telling you make sure that this is greater than 0. All right, so make sure you have to check that. Solve each equation, give the exact value or values. Example 7, we're going to have to make sure and double check that this thing inside here is greater than 0. And let's wait and do that at the end. Let's go ahead and solve it first. So if I want to get rid of that log base 3, I'm going to do an exponential base 3 on both sides, which would give me, I'm going to go ahead and FOIL this, 4x squared plus 4x plus x plus 1 equals 3 to the third power is 27. Cleaning up like terms, 4x squared plus 5x plus 1 equals 27, and then go ahead and subtract the 27 over for 4x squared plus 5x minus 26 equals 0. So we have a quadratic equation that we can solve. If we can factor it, sometimes factoring is going to be easier to do than other things, but if we can't factor it, maybe we use quadratic formula. This one is going to factor. I'm going to factor it into 4x and x. I need two numbers to multiply to negative 26. So remember, they're not going to add up to that 5. They're not going to add up to that 5 because one of the numbers is getting multiplied by 4. So if you do 13 minus 8, 4 times negative 2, 13 minus 8, that's going to do the trick. So I'm going to have a negative 2 on this side and a positive 13 on this side. Don't forget the equals 0, and that's how we're going to find our solutions. Our zeros are negative 13 fourths and positive 2. We think. We still have to check those answers though. Okay, so one way to do it is just plug those numbers in. Plug those numbers in for x and see if you get something that's greater than 0. So if you think that's easier for you, then fine, do it. Plug those numbers in and see if you get something that's greater than 0. Another way of doing it is to look at the domain. And what we would do is we would say, okay, this thing right here, this expression, 4x plus 1 times x plus 1 has to be greater than 0. And I believe we did this a chapter or two ago where we found the zeros were negative 1/4 and negative 1, and we thought about that kind of on a number line. Okay, so what I would do maybe is I would say, all right, if I FOIL this out, I know that's going to be 4x squared plus something. So I know that's going to be a parabola. That's going to be a parabola, and those numbers, negative 1/4 and negative 1, are my zeros. So since this has to be greater than 0, I would know that my solutions are going to be on this part of my parabola. Okay, and so we're thinking that that's going to be less than negative 1/4 and greater than negative 1. So if you looked at it on a number line, it might be easier for you to follow. We would have open circle, arrow to the left, open circle, arrow to the right. That would be the domain. The domain is going to be from negative infinity to negative 1/4, unioned with from negative 1 to positive infinity. Okay, that's the domain. So if you look at those numbers, negative 13 fourths is negative 3.25. Negative 3.25 is going to be somewhere over here on our number line. That's going to check out. That's good. And positive 2 is going to be somewhere over here on our number line, which that checks out as well. Both of those numbers work. So both of those numbers are part of our domain. That means both of those numbers can be solutions. Sometimes they won't both work. That's why it's going to be so important for us to check. Now again, if you don't understand what I just did there, the other way of doing it is taking those two numbers and plugging them into the problem. If you plug them in, plug one at a time, plug in negative 13/4 and negative 13/4 in here, and you get something that's bigger than 0, it works. If you plug in 2 in here, and it's bigger than 0, it works as well. So maybe you'd rather do that. Number 8. I see 2 logs, so we should be able to combine them into one log using our properties. Log base 2 of, we're going to have to multiply 2x minus 5 times x minus 3. I like to put it inside brackets here. Equals 3. Now keep in mind, this is going to have to be bigger than 0, and this is going to have to be bigger than 0. We can check that out later. So in order to get out of that log, you're going to do a base 2 on both sides. So the base 2, the exponential base 2 cancels out the log base 2, and you're going to end up with just this. So I'm going to go ahead and FOIL that out. 2x squared minus 6x minus 5x plus 15 equals 2 to the third power is 8. So cleaning up like terms, 2x squared minus 11x, I'm going to subtract that 8 over and get plus 7 equals 0. I don't know how to factor this one, so we're going to go ahead and do quadratic formula. Opposite of b plus or minus square root of b squared, that's going to be 121, minus 4 times a times c, all over 2 times a. So if we clean that up, inside the radical there, you're going to get 11 plus or minus the square root of 65 over 4. And if you approximate and type it into a calculator or something, you're going to get about 4.77 and about 0.73. Now we don't want that. We don't want those decimal answers because it said back in the directions to give exact values. But I think that's going to help me to know if my answers actually work or not. Remember, we have to go back and check the domain, and we have to say, well, 2x minus 5 is greater than 0. So if 2x minus 5 is greater than 0, add the 5 over, 2x is greater than 5, divide by 2, that means x has to be greater than 2.5. So we can already see right now that that number's not going to work. 0.73 isn't going to work. So x has to be greater than 2.5, but we also have x minus 3 is greater than 0, so x has to be greater than 3. So actually, the domain, all the x numbers have to be bigger than 3. So if you had to do the domain, it would be from 3 to infinity. But this number is going to work. 4.77 is in the domain because it's bigger than 3. So that is going to be a valid answer. Now don't forget, you have to give the exact answer. So let's just give this exact answer right here. The one that worked was when we added the square root of 65. And so the one and only solution that works, x equals 11 plus square root of 65 over 4. If we were allowed to approximate, we'd say 4.77.